Imagine you're standing on the side of a racetrack and a blindingly fast Formula One car tears past you. You hear it before you see it, a sharp, aggressive NEEEEEE that instantly collapses into a low, deep OOOM. We've all heard this sound 1,000 times, from passing ambulances to police sirens. But did you know that this single sensory experience contains the secret that scientists use to prove the entire universe is expanding? Today, we are cracking the code on the fastest, most dynamic physics concept you interact with every single day: the Doppler effect. We will simplify the physics using springs, and look at how this effect catches speeders on the highway and maps the edge of the cosmos. To understand the dynamic effect we are about to see, we first need to master the basics of how sound travels. We can break this down to a radically simple basic concept. Think of a slinky. If you hold a slinky and give it a pulse, an energy wave travels down the spring. Sound works the exact same way. Sound is just a physical wave traveling through the air. These waves are invisible, but they have a crucial physical measurement: the distance between each coil on the slinky. If the coils are close together, the sound is high. If they are far apart, the sound is low. Now imagine that slinky sound is attached to something that isn't moving. Think of a static object like an old alarm clock on a table. If the alarm clock goes off, it sends out sound waves. These waves travel outward in perfect symmetrical circles like ripples on a peaceful pond. If you are standing a mile in front of it or a mile behind it, the sound waves hit your ears at the exact same time interval. The spacing on that slinky is identical. This is why a non-moving object makes a boring, constant sound. Here's where the dynamic chaos begins. What happens when we put that slinky on something that is moving? Let's use the police motorcycle. As the motorcycle speeds toward you with its siren on, the sound is already on the move. But because the motorcycle itself is physically chasing the sound waves it just made, it literally catches up to them, physically squishing the waves together. Think of it like compressing that slinky. The coils are visibly tight. Because those waves hit your ear much closer together, the brain interprets this rapid arrival high frequency as a sharp, high knee sound. It is a mathematical traffic jam. But the moment the motorcycle passes you, everything flips. Now it is speeding away from you. As it moves away, it continues to make sound. But now it is physically racing away from the waves it just released. It is leaving its own sound behind. This means the sound waves get pulled apart and widely stretched out behind it, like stretching that slinky really far. 'Cause these stretched out waves hit your ear much further apart, low frequency. Your brain translates the slow arrival into that deep, fading OOOM sound. The physics didn't change. The physical spacing of the waves did. Here is the mind-blowing part. Everything we just simplified for sound also applies to light. If you understand the NEEEEEE-OOOM of a siren, you understand the most powerful concept in modern astronomy. If a star or a galaxy is rushing toward us in the cosmos, the light waves it is sending us are physically squashed, just like the siren. Scientists call this blue shift, and it means we see the light as slightly bluer than normal. If a galaxy is rushing away from us, those light waves are stretched out and pulled apart. Scientists call this red shift, and it means we see the galaxy as slightly redder. You interact with this invisible concept almost every time you get on the highway. We use it to catch speeders. A police radar gun does not guess. It applies the exact same slinky logic, but it uses radio waves instead of sound. The radar gun fires a wave at your car. That wave hits your moving car, is squashed or stretched by your speed, and is reflected back to the gun. The gun's computer instantly measures exactly how much your car squashed that wave moving toward or stretched it moving away, and calculates your exact speed. The data overlay on screen updates with the calculation. When you get that ticket, you aren't fighting the law. You're fighting inescapable physics. Here is a final, vital fact about the Doppler effect. We use it inside the human body. Have you ever wondered how doctors can check a patient's circulation without a surgical cut? They use Doppler ultrasound. The ultrasound machine functions exactly like the police radar gun. But instead of radio waves and cars, it uses sound waves and your red blood cells. The probe fires sound into your artery, and the sound bounces off your moving blood. The computer instantly analyzes the squashed and stretched sound waves and creates a real-time, colorful map of exactly how fast your blood is moving, ensuring your heart is functioning perfectly. When we listen to a car roar past us, we aren't just hearing a funny noise. We are witnessing the physical reality that everything in our universe, from sound to light to radio waves, is on the move. By mastering this single basic rule about the squashing and stretching of waves, scientists proved that almost every galaxy we can see is red-shifted, meaning they are all speeding away from us. The Doppler effect is the tool we use to discover that the universe is not static, it is actively expanding. This invisible effect allows us to map the speed of everything, from the smallest blood cell to the most distant star. Thank you for watching. We will see you in the next video.